Alright, welcome back. We're in Unit 3, which is quadratic expressions, and by the end of this our learning goals, or our big goals, would be to interpret and solve questions related to quadratic relations. And you'll know you've been able to get there if you can use problem-solving skills to create, solve an equation that involves binomial expressions, and we could also extend that a little bit further to include trinomials. So today, we should be able to solve these questions right now, and by the end of this lesson you should be able to solve the second question here. So just a quick review. Here's some look at how you can expand some forms and shortcuts in some cases, and specifically we're going to be looking at this one, these other ones here. This is expansion of a plus b squared. This is results in difference of squares, and this results in multiplication of a minus b squared, but specifically we're looking at this one up here. And we'll understand why as you get in. Just a refresher that going this way is expanding when we multiply and simplify, and going back, or if we start with x squared plus 3x and going backwards, breaking it into x times x plus 3, is factoring. So like this is considered division, multiple terms. We're going to look at factoring simple trinomials. We'll start with our overall learning goals for this lesson. To factor polynomial expressions involving common factors, trinomials, and we'll leave the difference of squares to the next lesson. It would be too much to do all in one. And I know that I've met my goal if I can factor expressions like these: x squared plus 3x plus 42, x minus 10x plus 24, and so on. And if you're really good, you should be able to answer this question by the end of it. We're going to start with a game, and here's the game. Give me two numbers that add to 5 and multiply to 6. It's like a linear system. X plus y is 5, and the other, x times y is 6. Those two numbers would be 2 and 3. 2 plus 3 is 5. 2 times 3 is 6. And so down below you've got these questions here, which you can try to do on your own. So I'd encourage you at this point to pause before we take it up. If your middle school teacher said you don't need to memorize your multiplication tables, you can just use a calculator because you've always got one, well, this is where it's going to hurt you, because knowing your multiplication tables is going to help you tremendously when it comes to factoring trinomials. And here's why. Well, it's going to be related to this stuff here. Two numbers that add to 3 multiply to 2. They are 1 and 2. Doesn't matter whether you put 2 and 1 or 1 and 2. 1 plus 2 is 3. 1 times 2 is 2. 2 and 8. 2 times 8 is 16, and 2 plus 8 is 10. 5 and 7. 5 plus 7 is 12. 5 times 7 is 35. 3 and 7. 3 plus 7 is 10. 3 times 7 is 21. Now your initial reaction for this one would be 4 and 7, or it doesn't exist, but actually it does. 2 and 14. And this is where it gets a little bit tricky for a lot of students. They might think, oh, well, this is minus 2 and maybe 3. But it's actually not. We know that one has to be positive, one has to be negative. And if you look at the factors of 6, you've got 1 and 6 and 2 and 3. It's actually going to be 1 and 6. And which one of these do I have to put a negative on? It's going to be this one, because I know that this number is negative. So the sign of this one has to be the larger number. Now this next one will be 2 and 9. Again, one has to be positive, one has to be negative for this to work, for these to be negative numbers. And I put the negative on the larger sign, on the larger number, because this is negative. We've got 3 and 6. And again, this is negative, so which one of these is going to be negative? It would be this one, because the larger number will make this positive when we add them together. Negative 3 plus 6 is positive 3. Negative 3 times 6 is negative 18. Practice makes perfect, and doing those ones will make you that much better. And here's the connection today. When we expand binomials in this factor, or this form, x plus a times x plus b, we get this x squared this middle coefficient is found by a plus b, and the last term is found by a times b. So how does that help us? Seeing the expansion in general helps us understand how to factor trinomials. This is a trinomial that's got three terms. Example, factor the following. X squared plus 6x plus 8. Give me two numbers that multiply to 8 and add to 6. Well, I could try and do it like this. 1 and 8. Get the factors of 8 and 2 and 4. And then I could try and see which one of these add to 6. If I ever got stuck, this is a good way to do it. 2 and 4 multiply to 8, and when I add them together, give me 6. So this will be equal to x plus 2 and x plus 4. And we have to keep them in brackets. And you could always expand out to confirm that this is right. Here's an example where we've got x squared plus 11x plus 30, and I'm going to show you maybe a demonstration of how to think of this differently using group factoring, just to show you that it in fact does work. So two numbers that add to 11 and multiply to 30 are 5 and 6. Again, if you got stuck, you could always go 1 and 30, 2 and 15, 3 and 10, and 5 and 6, and I don't need to go any further than that because it'll start to repeat. If you added all these together, you'll start to find that this one right here is the only one that will add to 11. So if I wanted to break this down or decompose that middle term, I could decompose into 5x plus 6x plus 30 on the end. And so what I'm going to do, I'm going to group these two terms and these two terms. I'm going to factor out the x from this first one. That'll turn into x times x plus 5. And on this other side, I've got plus, I'm going to factor out the 6. 6 times x plus 5. Notice here, this x plus 5 and x plus 5 repeats. So I can actually factor out the binomial. X plus 5. And what's remaining is this x plus 6, which goes in the other brackets. So this shows you that decomposition, I can actually go straight from here to here. It shows you that this is in fact true by using group factoring. And if you actually switch these numbers, you come to the same result, and I encourage you to try it out just to see what would happen. What does happen is that instead of having x plus 5 after the factoring, you'd have x plus 6, and this would be x plus 5 on the inside. So it is possible to mix them up and get the same result. Here we've got a few questions to test your knowledge, what's going on. Two numbers that multiply to 15 and add to 8. If you're confident with what you've seen already, I encourage you to pause and try and do these. If you still want to see more, then keep watching. 3 and 5, they multiply to 15 and add to 8. X plus 3, x plus 5. Two numbers that multiply to 30 and add to minus 11. They both have to be negative. And I know that 5 and 6 will multiply to 30, and negative 5 and negative 6 will add to negative 11. So technically I got two negative numbers, x minus 5, x minus 6. And this comes from practice. And again, if you ever got stuck, you could always try that writing down all the factors, 1 and 30, 2 and 15, 3 and 10, 5 and 6. But knowing that they're both negative is important because that will matter when you add them together. This will give you positive 30, negative 5 and negative 6 will add to give you negative 11. This one here, I know that it has to be one positive number, one negative number. And I know that the bigger number has to be positive. So the factors of 35 are 1 and 35 and 5 and 7. And like I said, the positive has to be the bigger number. The negative goes with the smaller one, because when I add these together, it gives me positive 2. When I multiply them, it gives me minus 35. X minus 5, x plus 7. Well, we look at this next one, and it starts to look a little bit more nasty because it's got that 3 in the front. We can't factor this as is. Notice up here it's got this factor fully. So we can actually take out the 3, divide each number here by 3, common factor first. 3 times x squared. 9 divided by 3 is minus 3x. And 84 divided by 3 is minus 28. And so now it turns into this thing of what two numbers multiplied to give me 28 and add to give me minus 3. I could look at the factors. 1 and 28, 2 and 14, 4 and 7. And right here, I know that I found that one of these has to be negative. And what I could do is I can just throw a negative on these things just to see what happens. And if I add these together, there's my 3. Negative 4 plus 7 is 3. It's actually on the wrong spot. I need to put the negative on the 7. So this will be equal to 4 times negative 7 is minus 28. 4 plus negative 7 is minus 3. I found my number. I must keep the 3 on the outside just because I found the numbers that make this thing factor. I can't just get rid of the 3. It's still there. X plus 4 times x minus 7. The next slide, you've got 4 questions. At this point, I'd encourage you to pause before I take them up. Now that you'd have a chance to try and do these on your own, I'm going to take them up. Two numbers which multiply to 18 and add to 9 are going to be 3 and 6, x plus 3, x plus 6. Two numbers which add to minus 15 and multiply to 56. They both have to be negative. They're going to be 8 and 7. X minus 7, x minus 8. They both multiply to positive 56 and add to minus 15. Here I need one negative number, one positive. Those numbers will multiply to minus 48 and add to 2. Those numbers will be, let's see here, in my mind I'm thinking 4 and 12 doesn't work. 6 and 8 would. Which one's positive, which one's negative? Well, the positive is here, so that goes with the bigger number. This is x minus 6 and x plus 8. Down here, I'm going to factor out a 2. Common factor. 2 bracket x squared minus x minus 40 divided by 2 is 20. Two numbers that multiply to give me minus 20 and add to give me minus 1 are going to be 4 and 5. But one of them has to be negative. Which one has to be negative? Well, the sign of this is the bigger number, so minus. This will be equal to, the 2 stays there, x plus 4 and x minus 5. It's also important to note that if you ever get stuck on these, you can always double check your answer by expanding and simplifying. And then you can be sure that you know you've got it right. And also double check 4 times minus 5. Well, that's going to be the minus 20. Add them together. 4 plus minus 5 is negative 1. So you should be okay with the expansion of this. Multiply through by 2. 2x squared minus 2x minus 40 is what we resulted with. This is one of the most important lessons of this year, and it takes an awful lot of practice. I've made this look easy because I've done so much practice when I was your age. And that's why, again, I encourage you to go back and do these questions here. I may also put up some additional worksheets online if you want the extra practice. Again, practice makes perfect. Thanks for watching.